Hello, Hornets. Thank you for joining me today. Today we're going to continue working with solving our trigonometric functions. And I've got some problems here where we're going to try to provide exact values when possible. And we will attempt to use our graphing calculators as we can. Alrighty, so in the first question, we will need to use our graphing calculator in order for us to find our non-exact values, whereas the other functions will be able to find them as we need. So let's go ahead and begin. Now, the first thing I want you to recognize is that we can factor this as it is. We can look at that as 3 sine squared and give me 3 sine of theta, and then have a 1 followed by a sine of theta and a 1. And now we just have to get that negative 2 sine theta. So if we multiply by a negative 1, we'll get a negative 3. And if we then multiply this sign by a positive 1, we will end up getting a negative 2 when we add them together. We're still trying to find them equal to 0, and therefore we're using our 0 property. Now, as we do this, keep in mind that we could also do it another option. I could, for example, define u as the sine of theta, and then this will allow me to use the dummy variable u to factor things that might seem a little bit more complex. Now I can call this 3u times 1u, 1 times 1. We still need to get a negative 2, and that would force me to multiply the 3u by a negative and the 1u by a positive. We then back substitute. So we now have 3 sine of theta plus 1 times the sine of theta minus 1. Now you notice it took me a couple of extra steps with the dummy variable, and some people aren't going to want to do that. You do not have to. This is entirely a choice of based upon how well do you factor. Now, once I have found that I have 3 sine of theta plus 1, I'm going to say that the 3 sine of theta plus 1 has to equal 0. And this is going to allow me to find that the sine of theta is equal to a negative 1/3. Now, this is a non-standard ratio. We're in degree mode, so I am going to have to put my degrees into this. So I'm going to go ahead, let me just turn off this light real quick, make it a little bit darker, but my hope is that I have less of a glare. Alrighty, so once again, I am going to put this in degree mode. We've talked about putting it in degree mode before. We bring it down to radians, we move it over onto degrees, and we click enter. Now, I'm going to use my arc sine. Now, please be aware, we know arc sine is only going to give us an answer that's a reference angle or the opposite of a reference angle. As a result, when I put the negative 1/3 in, I know I'm going to get the opposite of the reference angle. So if I take its absolute value, I'll be able to find it, and my theta prime is going to end up being 19.4712 degrees. Alrighty. Now our goal is to find our two answers. And we know that sine is in the third quadrant, it will be negative, and sine, being the y value, is going to be in the fourth quadrant to have our negative. We also know that in order to find our theta in the third quadrant, we're going to take 180 degrees, and we are going to add our theta prime. This ends up giving us approximately 199.4712 degrees. And we don't even need our calculator for that. The second one, to find theta in the fourth quadrant, we have to take 360 degrees, and we have to subtract the theta prime. Now, because of that, I'm going to go ahead and I'm going to use my calculator. Now, you'll notice I already have the negative 19 degrees, negative 19.4712 degrees. I can start by multiplying it by negative 1. Whoop, let's try that again. Multiplying by negative 1. It'll make it a positive. And then I can take 360 degrees and subtract that answer. Notice I end up with 340.5288 degrees. Once again, I have rounded to the fourth decimal place, and I'm going to include that. Now, once I have this answer, I have to go to the second one. We're going to start by saying that the sine of theta minus 1 equals 0, and therefore the sine of theta is equal to 1. This only happens in one place on the unit circle, at pi over 2 or 90 degrees. Since we are talking about degree mode, our answer is 90 degrees, and we would now list our answers in a solution set, or however your teacher wants it done. In my case, if I see all three answers, I will give you credit. If you put them in the solution set, I will still give you credit. So whether you put them in the solution set or not, if I can find the answer somewhere on the work, on the page that you've done, I'm going to give you credit. And we have it complete. Now the others are going to go ahead and they're going to work quite nicely. So I don't have to worry too much about them. I just have to be careful. And turn my light back on. So now I can look at this and I can see that I have the sine of theta secant theta minus 2 sine of theta. Sine of theta can therefore be factored out, leaving me with sine of theta times secant of theta minus 2 equaling 0. I'm now going to break it up just like I did in the previous problem. I'm going to take the sine of theta, set it equal to 0, just like taking the secant of theta minus 2 equaling 0. I know that sine of theta happens twice. On that unit circle, it happens right here and here. Notice that the points that we would have would be 1, 0 and negative 1, 0, and the sine is in the y value. So we're looking at pi in radians and 0 pi in radians. Do not include 2 pi as it is not part of the domain represented by the parenthesis. So I now have 0 pi or 0, and I have pi. Now we're looking at the secant of theta minus 2 equals 0. That means that the secant of theta is equal to a positive 2. Now, if you do not recall what your secants are, the reciprocals of cosine, I recommend that you rewrite it as cosine of theta is 1/2. This is going to happen whenever cosine is positive, and that's x values. So that's going to be in the first quadrant and in the fourth quadrant. In the first quadrant, I know that this is going to be my reference angle, and I will use that in order to find the fourth quadrant answer. If I have them memorized, I won't have to do that. So in the first quadrant, I'm looking at my reference angle is pi over 3. In the fourth quadrant, I'm looking at 2 pi minus pi over 3. I get my common denominator, so I have 6 pi over 3 minus pi over 3, and it yields the second answer, 5 pi over 3. Now, once again, I can see all three of the answers, and therefore I would give you credit. If you would like to be more specific, start with 0 pi, then go to pi over 3, then go to pi, and finish with 5 pi over 3 in your solution set. Voila, you're done. We now go to finding our multiple solutions. Now, you'll notice in this I go to 3 pi. Now, if I'm going to 3 pi, I'm going to probably want to know what is 3 pi in terms of the denominator that we will end up with as we find our answers. So I'm going to go ahead and I'm going to let alpha equal 3 theta. Now, this is a dummy variable and is not required. This is just something that I work with in order to figure out my reference angle and my starting positions. So here we go. I can go jump right to it if I know my ratios. Now, I know that this is going to end up being in the second and the third quadrant, and that the cosine has to be in terms of sixths. So I'm looking at 5 pi over 6, and I'm looking at, in the third quadrant, 7 pi over 6. However, for those of you who aren't sure, I can start by finding the reference angle. The reference angle will be the absolute value of this, and I will be working with the cosine of alpha equaling root 3 over 2, and that will tell me that the alpha prime is going to be pi over 6. Going to the second quadrant, I know that the theta will have to be pi minus pi over 6. Getting the common denominator, I'm looking at 6 pi over 6 minus pi over 6, and I will get my first answer, 5 pi over 6. Notice I already knew that if I know my ratios. If you don't, you'll have to find your reference angle and you'll have to go through the process. It makes it more complicated. Same thing. In the third quadrant, theta has to be pi plus the reference angle, pi over 6, and therefore I end up with our theta equaling 7 pi over 6. Once again, getting the common denominator 6/6 of pi, adding one more sixth of pi, and I end up with 7/6 of pi. We now go to our alpha. So our alpha is 5 pi over 6, and we are adding 2 pi k. This is because we are finding a sequence of values. Alpha then also equals 7 pi over 6 plus 2 pi k. Notice that this is the period for our normal cosine, the cosine of alpha. I'm now going to replace my alpha with 3 theta so that I can find all of my solutions within the domain. This will require me to divide everything by 3 so that my theta will end up being 5 pi over 18 plus 2 pi over 3k. Now you'll notice if I wanted to get this into the same denominator, I'm going to end up having 5 pi over 18 plus 12 pi over 18 by multiplying by 6 over 6. Now that means I'm going to keep adding 12 to the numerator until I reach 3 pi. Let's now stop and take a look and see what's 3 pi going to be in terms of 18ths. That's 3 times 18 pi over 18. This is giving me 54 pi 18ths. If I reach anything that equals 54 pi 18ths or greater, I have to eliminate it and I cannot use it. Keep in mind that we would then do the same thing for the second alpha in the third quadrant. 3 theta has to equal 7 pi sixths plus 2 pi k, and so I would end up with theta equaling 7 pi 18ths, and I would once again add 12 pi 18ths times k. We're now ready to begin and actually find every single solution. We start when k is equal to 0, 5 pi 18ths. We add 12 for 7 pi 18ths. We add 12 for 29 pi 18ths. We add another 12 for 31 pi 18ths. And we finish with 43 pi 18ths. Notice I don't want to go any further because I will go over 54. When I add 12, I get 55 pi 18ths. It's too much. We're then going to take this one. We start with k equaling 0. So we have 7 pi 18ths. We're now going to keep adding 12 pi 18ths until we reach a value less than 54 18ths of pi. So this is 19 pi 18ths. I add 12. Let's make sure I'm not messing up. I see there's an error. Right here, this should have been 41 pi 18ths. So notice I can see if I have a problem. I just go back and I check it and I correct it. So this one, notice this would have been my 53 pi 18ths, and I'm okay. It's under 54. There was a little bit of a problem as I was going along and adding. 5 plus 12 is 17, plus 12 is 29, plus 12 is 41, plus 12 is 53. 7 plus 12 is 19, plus 12 is going to give me 31, plus 12 is going to give me 43. And I don't want to keep going because I get the 55, which is too much. These are now my solutions around the unit circle. That's what we're looking for. That was our goal. Please be aware, these are some of the most difficult problems that I can give you involving your reference angles and involving our ratios. All right? This is what we did today, and I hope this made sense. Please remember, if you found this to be a positive video, remember to click like, and if you think that there was a problem, make sure you let me know and I will try to improve. Thank you very much. Be safe. Take care. Cheers, Hornets. Good night.